So before we move forward into Chapter 2, Lesson 8, we're going to pause for a moment and look at what we've already learned. What we've learned, we started with the very first lesson, which was 2.2a, when it came to the functions of mathematics. We always have those four main functions that we can do with different types of numbers: adding, subtracting, multiplying, and dividing. Our first lesson, 2.2a, was the adding part as well as the subtracting. And on that form that I gave you, and I told you to have in your math folder, at the top was the adding questions, in the middle was the subtracting questions. It always starts the same way. Can I add fractions? Can I subtract fractions? That question or that answer is always going to be yes. What do I have to have? Well, I have to have common denominators. Sometimes they're nice and say, well, here's a common denominator. Let's make your math easier. Then I would keep the denominator and either add the numerators or subtract the numerators. When I get to the answer, then I'm either going to reduce, or if it's top heavy, I'm going to convert it. I want to change it into a mixed number. A lot of the times, though, they're like, we're not going to be nice to you. You have to find a common denominator. The way that we'll always work on common denominators is I multiply by opposite denominators. So whatever's over on the right, I'm going to multiply top and bottom on the left, and whatever denominator's on the left, I'm going to multiply to the right, top and bottom. I rename them, not changing the value, just changing the digits that make up the fractions. I would keep the denominator, I add or subtract the numerators, and then I simplify or reduce. With multiplication, it was a lot easier, wasn't it? We just said, okay, I just need to multiply straight across, either numerator to numerator and denominator to denominator, or, as in this example, I could cross reduce. Diagonally, we can see that 4 and 12 have a common factor. 4 went into 4 once, 4 goes into 12 3 times, and then diagonally between 9 and 6, 3 goes into 6 twice, and 3 goes into 9 3 times. Then whatever I'm left with, I can multiply straight across and get to that, in that case, an improper fraction, which therefore I would still have to simplify. And then we left off with the division of fractions. We cannot divide fractions, so we know there's 3 steps we have to go through. We have to keep the first one. We have to change division into multiplication, and then it's that reciprocal of the second one, just flipping that fraction upside down. Then we're left with multiplication, which takes us straight back to this lesson here. So before we jump into lesson 8, we're going to do a quick review just so our minds remember what it is that we've done, and it's just extra practice to make sure that when we get to our test in 3 lessons, we're ready for it and we understand our processes. So we went from this book, you don't need it today, I'm just reminding you that this is where 2.2a came from, with the adding and the subtracting of fractions. So we had those questions that we always asked. Once again, can I add fractions? Can I subtract fractions? That answer is always yes. What do I have to have? I have to have a common denominator. It's impossible if I don't have a common denominator. Because then what do? I'm going to keep that denominator if I have it. And if I don't have it, then I have to find it. And by finding it, then once again, the way that it always worked was multiplying by opposite denominators. We're going to work through a couple where I use the opposite denominator process and where I look at the smallest common denominator. So with the questions over here, then, these should look familiar because these are the same practice problems from the book. I'm just reviewing what we've already gone through. The assignment won't be directly from the book. I've created you a worksheet so that we have them all mixed together so we can practice the steps and the functions that we've already learned before we get into a little bit more complicated division. So I have 2/3 plus 1/2 on my paper at the very top. I ask if I can do it. Yes, I can indeed add. Do I have a common denominator? No, indeed, I do not. So the process that always worked was multiplying by the opposite denominators. I say it every time we do a video. Please follow along. Make sure your ears are engaged, your brain is engaged, your hand has the pencil in it, and you're ready to write down your notes and go with me. So step by step, I'm going to multiply by the opposite denominators. On these lessons, once again, we weren't estimating because we have a whole lesson on estimating, which we'll get to later on. I can do the least common multiple, or the least common denominator was how the book mentioned it, or I could just multiply by opposite denominators, which is what we're going to do on this one. So I have a 3, so I multiply numerator and denominator by 3. and I have a 12, so we multiply by 12 in numerator and denominator. That's going to give me the same denominator, which will then allow me to do my work. So then in this space here, they show you that we have a denominator 12. Well, that's where I said we're going to just multiply by opposite denominators. So what we're actually going to have is 36, because 12 times 3 is 36, and then the 12 times the 2 is 24. And on the right-hand side, on the left was a 3, so on the right-hand side I have 3 times 12, which is 36. Notice common denominators. And then 3 times 1, which is 3. Once I have the common denominator, what do? I simply keep it so I can then do my math. So I kept my denominator of 36, and then I add my numerators. 24 plus 3 is 27. Then once I've done that, I see if I can reduce it. Is there a number that will go into 27 and 36 evenly? So you may see that 3 will, because 2 plus 7 is 9, and 3 plus 6 is 9. But because they both have the answer of 9, we said 9 will also go into them. So I may reduce by 3, but then I'd reduce by 3 again, where if I reduce by the 9, I can reduce in one step. 3 goes into 27 3 times, and 3 goes into 36 4 times. So my final answer is just 3/4. On the second one is subtraction. Can we subtract? Yes. Do I have a common denominator? Yes. So I keep it. Some of the errors that I saw on the assignments and still on one of the review lessons was you were subtracting your denominators, and on this case you end up with 0, and that gets really confusing when 0 is in your denominator. So you have to remember, keep that denominator. So I keep 18, but the subtraction is done with my numerators. So once I keep 18 as my denominator, I take 11 minus 3, which is 8. They're both even, so I know 2 will go into both of them. If I do a quick run through of my factors that could go into it, 3 cannot, because 3 doesn't go into 8 evenly. 4 does go into 8, but it doesn't go into 18, because that would have to be 16 or 20. 5, neither one in was 0 or 5. Not 6, 7, 8 is the only other one, and 8 won't go into 18 evenly. So I know 2 is the only factor I can use on this one. So I reduce. Once again, reducing is dividing numerator and denominator by the same number. So 2 goes into 8 4 times, and 2 is going to go into 18 9 times, which ends up giving me a final answer of simply 4 9ths. On number 3, we're not going to do the opposite denominators because I want to work through one of each where I could find the smallest common denominator. So when I look at it, I know I can add them, but I don't have the common denominator. Then I ask, does the smallest denominator, the 5, go into the 15 evenly? And it does. So that says, okay, then keep the 4/15 in the math problem and just change the second one to where it has a 15 as its denominator. So if I keep the 4/15 and I need 15 in my denominator, I have to ask, well, what would I do to 5 to get 15? So I know I'm going to multiply it by 3, and therefore I have to multiply the numerator by 3. Not changing the value, just changing the digits. So this 15 will stay the same. This one will become 15. So that 4 would have to stay the same, and 3 times 2 gives me 6. Now that I have the common denominator, I'm going to keep it to work with in my answer. I add my numerators. 4 plus 6 is 10. And I know that if it ends with 0 and 5, I can reduce by a 5. So I'm going to divide top and bottom both by 5, which will give me 5 going into 15 3 times, and 5 going into 10 2 times. So I just end up with a final answer of 2/3. All right. This is where we had the introduction to algebra. And it seems really complicated, but when I explained it to a couple of you that didn't get it the first time and you asked, you're like, that's all I got to do? That's all you got to do. They're telling you that this is your math problem, 7/16 plus y, and they just want you to plug in for y the 3/4. So they give you the 3/4, you just plug it into the place of that y. So if I have 7/16 and I plug it in, I'm going to do the same thing over here. It doesn't matter what the letter is. They can use any of the 26 letters in the alphabet to give you an algebra. If they tell you what that number is, then they just make it easy. They say plug it in for that missing number. So when I plug 3/4 in, then that becomes my math problem. I could multiply by opposite denominators, but I should be able to see that this 4 goes into 16 evenly. So I could keep my 7/16 and use that as my common denominator. Or if I want to, I can just multiply by the same number, or by opposite denominator, excuse me, and end up with the same answer when I get through it. So let's do it that way. Let's say I'm going to keep my 16 and I'm going to multiply over here, and then I'm going to have my 4 and I'm going to keep it, but I'm going to multiply over here. That's going to cross multiply and get the same denominators when I get to my answer. So I have 4 times 16 and 4 times 16. Both cases give me 64. So then I multiply it over here by 4 in the denominator. I multiply in my numerator 4 times 7, which is 28. And over here I multiplied by the 16, which gave me my 64. So in my numerator, 16 times 3 gives me 48. Now I always keep my denominator when I'm adding and subtracting. So I know I'm going to have a denominator of 64, and if I need to, get my handy dandy calculator and type in 28 plus 48 equals, you're going to get 76. Couple problems there. Number one, I can reduce it. I know because they're both even numbers. Number two, it's top heavy, isn't it? It's an improper fraction. So I know I'm going to have to convert it. I'm going to have to change it into a mixed number. Which one always, always, always goes inside the division box? Hopefully you said the top number. That will always go inside the box. It doesn't matter if it's more, it doesn't matter if it's bigger, it matters that it's my top number, which is my dividend. So 76 goes inside. I'm going to divide by 64. 64 does go into 76 one whole time, and then I have a remainder, don't I? Because when I type it into my handy dandy calculator, I have a 12 left over. Well, my remainder is always my numerator. And my divisor will always stay the same. So I have one whole with a remainder of 12 for my numerator, and my divisor of 64 is my denominator. Now I have to reduce. Now I could have done it in reverse and reduced here, but then I still end up with a top heavy or an improper fraction that then I have to divide. Either order, it does not matter, because you can still get and should still get to the same answer. But when I reduce both of these, they are even, but I'm going to reduce by 4 instead, because 4 is my largest, my greatest common factor, my largest number that will go into both of them. And 4 goes into 12 3 times, and 4 goes into 64. If I type it into my calculator, easier math, I see that it's 16 times. So my final answer becomes 1 and 3/16. Now on number 6, instead of adding, it's subtracting. So when I subtract, I just have to make sure that in my final step, I do the subtraction and I make sure I do the math. Some of you, as you were going through your homework assignments, you weren't looking at that sign. And so a lot of you, you just simply missed it because you did the opposite. Just always check the sign before you actually do the math. When I look at it though, I'm going to see that I have a 6. Here I multiplied by opposite denominators. Let's do it, just so it's good practice, by multiplying to find the smallest common denominator. 6 indeed does work because 3 goes into 6 evenly. So if I keep the 1/6, then the only thing I have to change is the 2/3. And how do I get the 3 into a 6? I'm going to multiply by 2. And whatever I multiply the bottom by, I have to multiply the top by that same number. So I know I'm going to change that into denominators of 6. And then in my numerators, the 1 would stay the same, but 2 times 2 is indeed 4. Now I have a common denominator. The way that this is easier is, a lot of times I don't have to do as much when it comes to reducing. I'm still going to have to reduce sometimes when I get to my answer, but it does give us smaller numbers also that we get to work with. Either of these ways to get my denominator, common denominator, is going to be just fine. I don't care which way you do it because you have different ways you can do math problems and always be successful. But once I have my common denominator, then I know I have to keep it. So I have to have 6, and then I check, I am subtracting, so 4 minus 1 is going to give me 3. Now I know that I'm going to have to reduce because I know that 3 automatically goes into 6. So I'm going to reduce by 3s, and 3 will go into 3 one time, and 3 will go into 6 2 times, which gives me a final answer of 1/2. All right, so then we went to our multiplication. So this was our screen for lesson 4, right? And then we also added that extra step then in lesson 5, and we cross-reduced anywhere that we possibly could. So once I cross-reduced, then I reminded myself, well, I know I can multiply fractions, and how do I do it? I multiply straight across, numerator to numerator, denominator to denominator, and then I would just have to reduce if I possibly can. Once again, make sure you're following along as we continue forward. So when we got into these then, these are all set up nice and even for us. We don't have any mixed numbers or whole numbers. Just a quick reminder, whole numbers always go over 1. And then our mixed numbers, I have to start at the bottom and multiply and add and get an improper fraction. These are pretty straightforward, but I do have cross-reducing that I can do, which they showed you on the setup of this problem. So make sure you're following along and you understand what's going on. It is going to be on your homework assignment. So when I have them set up then, we just rewrote them and made them a little bit bigger, and I look always diagonally. So I know that 3 and 6 can reduce and 5 and 10 can reduce. So when I'm going to reduce those, then I'm going to take 5 and 10, reduce them by 5s. 5 goes into 5 one time, and 5 goes into 10 two times. So I now have 1 and 2. And then my 3 and 6, I'm going to reduce by 3. It will go into both of them. So if when I reduce by 3, I have 3 going into 3 one time, and 3 going into 6 two times. Now I'm left with my lowest numbers that I can possibly get. I'm multiplying, so I just multiply across. So I always show those arrows and I connect to the numbers that I have left so I can see what I need to multiply by. I have 1 times 1 in my numerator and 2 times 2 in my denominator, so I'm just left with 1/4. It can't be reduced, so I'm good to go. On number 2, I check out to see what I can cross-reduce. 4 and 5, I can't cross-reduce those, can I? Because 5 is a prime number and 4 doesn't go into it evenly. So 3 and 9, I can see that I can cross-reduce those. So I know I'm going to be multiplying whatever I have once I cross-reduce them. So I have 3 and 9, 3 goes into both of them. So I'm reducing, or I'm dividing by the same number. 3 goes into 3 once, and 3 goes into 9 3 times. So I'm going to have a numerator with a 1 and a denominator of a 3. Now I'm just left with what's left, and I'm going to multiply across. So 1 times 5 is 5, and 4 times 3 gives me 12, and then I see if I can reduce any more. I can't reduce anymore. If I get to an answer where I find out that I can still reduce over here, then I need to, but most likely what will happen is I just didn't reduce by the largest common denominator, and that's fine, as long as I make sure that I reduce for my final answer. But here 5/12 is as low as I can go. And then on number 3, we have both ways that we can reduce. I can see my 3 and my 9, and I can see my 2 and my 10, so I'm going to cross-reduce until I can't reduce anymore. 2 goes into 2 one time, and 2 goes into 10 5 times. With my 3 and my 9, I'm going to reduce by 3s. It's the smallest number that will go into both of them. 3 goes into 3 one time, and 3 will go into 9 3 times. Now I'm just left with multiplying across. 1 times 3 gives me 3, and 1 times 5 gives me 5. So 3/5 is as low as my answer could possibly go. Then we got into the division of fractions. And I said, you know, it's kind of like the whole frog leg idea. I love them, but most of my family just doesn't even get why I would eat them. So with this math lesson, some of you really get it. I said put it in your back pocket. It is a good tool for you to go back to anytime you get stuck on a division of fraction problem. But for most of us, we didn't get it. We got really frustrated. And that's when I said, it's okay. Forget it and move on, because I'm not going to ever make you do it, but it is going to be helpful for some of those who really got it. Then we got into the actual steps of division. And we said from the very beginning, we cannot divide fractions. So I know that there are steps that I have to do. And we're moving forward. We skipped lesson 6 because it was all about estimating, right? And I said, there's no reason to estimate when we have a whole section on estimating that we're going to go through. Let's go in and learn how to divide. And that's where we left off last week. We said our steps were simple. I know I'm going to keep my first fraction, I'm going to switch my division to multiplication, and then I'm going to flip my second fraction. And I had a couple people that came to me, I can't get this, I don't know what I'm supposed to do. And I ask, can you give me your paper where on the front was subtraction, or addition, subtraction, then multiplication, and then on the back was all the steps for division? No, I lost it. Okay, then on the video I told you to write them down. Did you write them down? Well, no. We got to help ourselves, right? And if I'm telling you multiple times, hey, it's going to be helpful to write it down, then write it down. And if you don't have that original paper that I gave you, I'd advise you to write it down so that you have them. You can have it on your own piece of paper, stick it in your math folder, pull it out anytime we're doing these type of problems. Same steps will always happen. So I'm going to start out with this 2 divided by 1/8. Now, multiplication and division work the exact same way when it comes to whole numbers and mixed numbers. I can't use either one. So we said from the very beginning that all whole numbers have to go directly over 1, so it is indeed in fraction form. So when I have 2 over 1, then I can look at what I'm supposed to do. So I always keep my first one, so I'm going to bring down the 2 over 1. I'm going to change division into multiplication, and then I'm going to flip that second fraction. So I end up with 8 over 1. See if I can cross reduce. No, because my denominators are at 1, and that's as low as I can go. So I'm just going to multiply across. I end up with 16 over 1, and that is as low as my answer can go. However, I know that if I have a number over 1, I have to change it into a whole number. And how do I do that? I just drop that 1 off, and I have the whole number that's in the numerator. Number 9, same thing. I'm going to go through my 3 steps. I'm going to keep my first one, so I'm going to bring down to 3/4. I'm always rewriting these, right? So that I can see how I'm setting it up instead of trying to do all this mental math, because the mental math is really what's messing some of us up. Division is going to become multiplication, and then I'm just going to flip that second fraction. Once again, that word is reciprocal when I take a fraction and I turn it upside down. Now that I have it, I check to see, can I cross reduce? Because I'm back to a math problem that I know how to do. I know how to multiply fractions. And I can indeed cross reduce. And I said anytime that it's a same number, I just mark them out and they become 1s. Because it will always cancel each other out. Now I'm left with 1 times 5, which is 5, and 4 times 1, which is 4. That's one of those top-heavy, the improper fraction, and I know which one goes inside my division box. Hopefully you thought the top number. It's always my dividend. So now I can divide. 4 does go into 5 one whole time, and that gives me a remainder, because 1 times 4 is 4, with a remainder of 1. My remainder is always my numerator. My divisor is always my denominator. So my final answer becomes 1 and 1/4. I check real quick just to make sure I can't reduce my fraction, and indeed I cannot. 1/4 is as low as I can go. And then they threw in some of these order of operations. So just as a reminder, I have absolute value, square roots, exponents, and parentheses. Ask for several extra presents. Then we go to division and multiplication, right? My dear, multiplying and dividing from left to right, whatever comes first. And then I have adding and subtracting, Aunt Sally. Ask for several extra presents from my dear Aunt Sally. Making sure I follow my order of operations. We noticed on the first time we worked through these are the exact same numbers with the exact same symbols in between, but we got the different answers because the parentheses tell me to start here, where order of operations tells me just to start with my division. So in my fractions, adding of fractions, which we just reviewed a couple minutes ago, I know I can add fractions, but I have to have a common denominator. So my common denominator, when I look at it, I know that 10, well, 5 will go into that, so I'm just going to keep my 1/10. I'm going to change my 5 into a denominator of 10 so I can actually add these together. What would I do to 5 to get 10? I'd multiply it by 2. So if I multiply my denominator by 2, I have to multiply my numerator by 2. Then I just multiply and create my new fraction. 2 times 5 is indeed the 10 that I need, and 2 times 3 is 6. What do I do with my denominator? Once I have the common denominator, then I simply keep it. And then I add my numerators. Well, I'm adding because 6 times plus 1 then is going to give me 7. Now I'm not done. I only did the first half. I did the parentheses. It's set up then as division. So going back through those steps, I'm going to keep that first one. Well, It's 7/10, and it's already down here, so I'm just going to keep it where it is. I want to bring everything else down. Division becomes multiplication, and then that's where I have a whole number of 2, which we said we can't do. So I have to start by putting it over 1 so I don't accidentally change it and make it incorrect down here. If I know this starts out as a whole number over 1, then when I find the reciprocal, I can put the correct reciprocal of 1/2 down below. Now I'm going to check to see if I can cross reduce in my multiplication. Well, 1 and 10, 1's as low as I can go. 2 is a prime number and it does not go into 7 evenly. So now I'm just left with multiplying across. 1 times 7, 2 times 10, I end up with 7/20. It is as low as it can go. So 7/20 is going to be my answer. Now on this one, I have an addition followed by a division. When I have my absolute value, square root, exponents in parentheses, and it's not there, then I have to look directly at multiplication and division from left to right. I ignore addition and subtraction until I get to it. I know I have a division problem here, so that's where I have to start, and I do indeed get a completely different answer. So I'm going to keep my 1/10. I know, according to my steps, the division becomes multiplication, and then I'm flipping that second fraction. So when I have my 2, once again I had to put it over 1, I flip it, it is indeed 1/2. Then I'm left with multiplication, and I multiply across because I can't reduce since both numerators are 1. 1 times 1 is 1, and 10 times 2 is 20. Now what I have is 3/5 plus 1/20. So I usually prefer to stack my fractions. It is not required. I just think it's easier to see, especially when I don't have a common denominator. So I have my 1/20, and I'm adding 3/5 to it. I can see that 5 goes into 20 evenly, so I'm going to keep my 1/20 because that'll be my common denominator. So then I have to multiply 5 by 4 to get the 20 that I'm needing for my common denominator. So 4 times 5 is 20, and 4 times 3 is 12. Now that I have my common denominator, I'm simply going to keep it. So my denominator is 20, and then I add my numerators. 12 plus 1 is 13, and that one cannot be reduced. So I keep 13/20. All right, so I've created a worksheet. Worksheets should be a lot easier because it's things we've already learned. A couple of them are things that we've already reviewed. I just added the division in it since we were gone for a weekend. I just want to make sure our brains are awake because in a couple of lessons, we have our test. Chapter 2 should be pretty easy as long as we're following along and we're truly learning these things. So on the worksheet, you have front and back. You're going to do all of them for your homework. Come and ask if you have any questions.